So, yesterday we left off doing L'Hopital cases where you have a limit that comes out to indeterminate or 0 over 0 or infinity over infinity. You investigate further into the matter by comparing the rates of change or the derivative over the derivative and then taking the limit. Yeah? We didn't get through this one, so I'll warm up with that and then we'll go on to the back side, all right? So this guy, as x goes to 0, what is arc sine of 0? Or what angle is sine 0 at? 0. What about x? As x goes to 0, x goes to 0. Is that an indeterminate form problem?
Yes.
It is. Therefore, by L'Hopital's rule, we can evaluate the limit by comparing their derivatives. The first one, or the numerator, requires some skill on your part. What's the derivative of arc sine of 2x? 1 over root
1 minus 2x.
1 minus blank squared, and you said, in this case, the u is 2x. But then via chain rule, times 2 because of the derivative of the inside, right? All right. The numerator is done. The denominator derivative is 1. All right. If I evaluate that at 0, the top is 0, the denominator is 1 minus 0, so this limit is 2. Check? Okay. Now then, sometimes in the worst case scenario, you do L'Hopital and your new limit is still indeterminate, in which case you must do L'Hopital again. All right? So, let me say something like this. This guy, the top is 0 minus 0, the bottom is 0 minus 0, so I'm feeling L'Hopital, and I start showing the work properly. Do not just write this. That is bad math. It won't be taken on the AP test. You need to do show each limit is 0 separately. The top does go to 0. Do you agree? The bottom goes to 0. Do you agree? So by L'Hopital, I can instead do the limit of the derivative. Now, I don't use the quotient rule. We talked about that yesterday. Instead, we just take each derivative because we want to compare the rates of change, not find the overall rate of change of the whole thing. So the numerator derivative, carefully, the derivative of sine obviously is cosine, but on the second part, we're going to be careful with the negative. We're going to be careful with the product rule. So I'm going to factor the negative out front and then say, what's the derivative on x cosine of x? X times negative sine of x for first times the derivative of the second plus cosine of x for second times the derivative of the first. All right? The denominator, what's the derivative there? 1 minus cosine of x. If we do a little bit of cleanup first before we proceed, how does the numerator simplify? What happens to the cosine? They drop away, subtract away, and so we have positive or negative x sine of x. Positive x sine of x. The denominator is pretty simple. We're good. Giving that a quick mental look at it, is this going to be something I'll be able to do? The top goes to 0. The bottom, what's cosine of 0? 1, and 1 minus 1 is still 0 over 0, right? Which means it's an indeterminate form again, so we're going to do L'Hopital again. Thank you. So by that same process, we're going to show each individual limit. The limit as x goes to 0 of x sine of x is 0, and the limit as x goes to 0 of 1 minus cosine of x is 0. So by L'Hopital again, the the original problem, and therefore the derivative problem, and therefore this new problem is equal to the limit of, what's the new derivative? X cosine of x plus sine of x. All right? The numerator is done. What's the denominator's derivative? Positive sine of x. The top, what does it go to? 0. The bottom, what does it go to? Also 0. So sadly, we're going to do L'Hopital a third time. The limit as x goes to 0, x cosine of x. Probably should have started you with just a double L'Hopital instead of a triple. Or maybe it'll be quadruple. Who's to say? X cosine of x plus sine of x goes to 0. The limit as x goes to 0 of sine of x goes to 0. Do you have room on this in your notes? There's always the bottom. So by L'Hopital, there's no bottom, you're at the bottom? Oh, there's no room? Oh, well, you work it out. All right, so the third, is this the third time we've done L'Hopital? Yes. Okay, so what does the numerator become now? Derivative of x cosine of x, negative x sine of x, plus cosine of x. That's all we needed. Boom, that's going to be great because that'll be a 1. What about the derivative of sine? Plus cosine. All right, the derivative in the denominator? Cosine. All right, now, what does the top go to? 0 plus 1 plus 1, so 2, and the denominator goes to 1, so all together this is 2. The limit is 2. All right. Now, that's pretty rare. You have to do it 3 times. I probably should have started off with the double. You try this guy, please. And feel free to talk it over with your mathematics. Do not think for 1 minute that you'll be able to master this by watching me and not trying it yourself. It takes practice. Way to wear me down, so now that I'll take pretty much. Are you ready? Yes. All right, how are we doing? This is what the work following to the answer should look like. Hopefully you did something like this. You mentally looked at it and said this top goes to each, a huge goes to infinity. Infinity, oops, squared or huge squared is also infinity. Infinity over infinity is another indeterminate form. 0 over 0 and infinity over infinity are I don't know what they equal. It depends on how fast they go. Question. Indeterminate. So by L'Hopital's rule, we compare their derivatives. And we take the original problem and we say, what happens if I take the derivative by chain rule? What's the derivative of e to the 3x? E to the 3x times 3, or 3 to the 3x, depending on where you put that. Okay? Again, fight the temptation to put infinity over infinity here. Instead, look at it, say, oh, it's going to be infinity over infinity. I need to show the work properly. And you show each separately. 3 to the 3x is infinity. 2x is infinity. So by L'Hopital again, the limit as x goes to infinity of, what's the new derivative on the numerator? 9 to the 3x over the denominator. 2. Is that indeterminate form, or is that, I know what that equals. I know what that equals. 9e to the 3x at huge x's goes to infinity. And dividing it by 2 doesn't mean nothing. Your answer is infinity. How'd that go? Okay. Would you do the one below it, please? The lower right. How we doing, people? Is it indeterminate? Not ever assume it's indeterminate. E to the 3x at negative infinity. E to the negative infinity. There's two ways to look at that. You can think analytically. What does a negative exponent mean? In the denominator. And so that would go to 1 over e to the huge, which goes to 0. You could also think graphically. At x goes to negative infinity, y goes to 0. Okay, so the top goes to 0. I'll see if I need to show that well. The bottom goes to infinity, negative infinity, huge number squared. Is that indeterminate? Tiny positive numbers divided by huge positive numbers. Is that I don't know, or is that I know? What is it? 0. That's not an indeterminate form. The limit is 0. So the key to any skill is knowing when to use it and when not to use it, just like use of and all that. L'Hopital should only be used when it's appropriate to do so. I think I'll blow that one off in the interest of time and go to this guy. Would you, this is an AP question in a recent exam. See if you can make your way through this. This combines two skills, which is pretty common on the AP test. Skill synthesis. Haley, are you okay on your makeup? Or you still have a little to do?
I think I only had one set, right?
Okay. I don't understand. Oh, that would be interesting. or almost through it. It just, I didn't get through well. All right, how we looking, people? Not yet, or go, go, go? Great. Let's get discussions happening. Yes. Oh, thanks. Single powered one is the identity. The identity goes into a square. So I don't want you to develop that. Yes. Or it is. So I feel like G isn't a triangle so much as an area accumulation function from 0 to wherever. So if it's 0.3, well, it goes to, so what is the, as you go from 0 to 3, what's the net area? Just think, these are the same triangle, but one's positive, one's negative. So G at 3 will be the integral from 0 to 3, which would be the net area accumulation of 0. So the top goes to 0. The bottom goes to 0. So it's a case. So you're going to show that each of these goes to 0, or state that, and then take the derivative of the bottom using what the touch rule. All right, how are we doing? Are we ready to talk? Of course. Okay, not yet. One more minute. Kind of a crafty problem. They've got Spears competition. You get one of your problems selected by the AP or the College Board. You have to write really good problems. This is a really creative problem. So let's talk about G. G is an area under the curve or area accumulation function. G at whatever points represents the area accumulated under the curve, the signed area accumulated from 0 up to 1 to some point. Now here they're talking about as x goes to 3. So G of 3 would be the integral from 0 to 3 under this curve. What is the integral from 0 to 3? Well, that's a net of 0. The top goes to 0. The bottom, just by straight up algebra, goes to 0. So it's a L'Hopital case. We should start by saying, all right, the limit as x goes to 3 from below of g of x is 0. The limit as x goes to 3 from below of x squared minus 9 is 0. And so by L'Hopital's rule, the limit is equal to the limit of the derivatives. I'm just going to call it g prime, and the denominator is 2x. All right, now I need to go a little deeper. What's g prime the same? F double or just straight up f? Yeah, if I take the derivative of this side, g prime would be the derivative. So the derivative of the antiderivative is just f. So you would then communicate that to the person, say, hey, g prime is the same as f, 2x stays the same. Now let's see if we can evaluate. At 3, what is f at 3? Is that the area, or is it just the point? The point. F at 3 is negative 3. What about the denominator? What does it go to? 6. And so our answer is negative 1/2. Okay? Are you tracking? All right. That's the kind of thinking. You need to just get gradually more and more used to, okay, I haven't done a problem like this before, but it's based on 2 skills I can do. Put them together. Don't freak out. Just think your way through it. All right? That's what you're practicing now. It'll be there when the test comes. All right. That is the end of 79. Now let's go to set 80. Okay. Should we do a L'Hopital warm-up off set 80? Or just go to the notes? Alright, that was an inconceivable mess, right? Yes? Okay. This is on set 80. Would you do 11 and just do 11? 23 is not L'Hopital. Do 11 as a warm-up, please, on set 80, the new sheet that you just had on your desk when you walked in. Please. Monday. Unless there's a snow day, it's Monday. We're gonna 5 sets this week. That's a lot.
We had a lot.
That's a strenuous pace.
And we have Mercedes on Saturday.
It's rough. It's
I
rough.
know. So
We have a budget summary and
We should just get to work as fast as possible then.
what I heard is Tuesday.
I didn't hear Tuesday.
Love it.
I do respect you, and I do love you guys, but that's because I love you that I gave you this homework.
I feel like that's not.
I feel like those go together. Definitely. Are we ready? Don't worry about 23. Just make sure you have 11 done. 23 is arctangent. We've done that a little bit. So if you want to write arctangent in the box, fine. But let's focus on this one. So just mentally, wouldn't you agree it's infinity over infinity? So it's a L'Hopital case. All right. So then we start showing the work properly. The limit as x goes to infinity of x squared goes to infinity. The limit as x goes to infinity of log of x goes to infinity. And so by L'Hopital's rule, the limit as x goes to infinity of 2x over 1 over x. I could do the limits that way, but I prefer to clean it up as I go just to make my life as easy as possible. Do the algebra to make your calculus go well. How does that clean up? 2x squared. That's actually not a fraction at all. I don't know why I wrote that bar there. So, is that indeterminate anymore? Boom, it's just infinity. Okay? Say in the multiple choice you didn't see infinity. What's another possible answer? Yeah, it does not exist. Remember, technically a limit is supposed to be what numerical y value the graph approaches, and this isn't a numerical value. So they would either give you infinity or it does not exist. But it would never be both. Okay? All right. Let's go to rational functions. This is actually a pre-calc idea, but they don't teach it. In our Saxon book doesn't have this idea. Hopefully, it'll go well. So, check this out. This is a rational function because it's a ratio of polynomial expression. Right? That's what a rational function means. It's typically characterized by a bunch of asymptotes all over the place. So, this is the process. First, look for holes. Helps to factor it before you look for holes. I see it factoring this way, okay? There's a hole if, what? How do you know if the graph has a hole or not? Yours is completely different?
Well, not completely. It's just a 5 instead of a 9.
Yeah, 9, I was going to say, 9's going to have to change the scale. So this is a 5 here?
Yeah.
Okay. And everything else is the same?
Yeah.
Okay. I don't know what I was thinking about that 9. All right. Thank you for telling me before I got too far. Now, there's a hole if 0 over 0. Okay, 0 over 0 indicates there's a hole in the graph. It doesn't exist necessarily. It just means I don't quite know what's there. graphically, actually, there will be a hole then at x equals 0. But the question is, what's the y of the hole, yeah? I know I can't put a point there. It'll be a hole. But how do I find where the hole is y, Scott? And if I remove the hole, if I mark the hole as at x equals 0, and then put x equals 0 in here, then what do I get? Y at 0 approaches negative 4/5, right? So there's a hole in the graph there. You follow? All right. So far I have graphed where it is. Good job. Now let's graph where it is. The other issues are actually, sorry, when the numerator is 0. When the numerator is 0, what's happening graphically? If I put, for example, 4 in to the equation, what do I get for y? 0. So if the top is 0, if the numerator is 0, then y equals 0, or it's an x-intercept. So I have an x-intercept at 4. What about if the denominator is 0? Then you have a vertical asymptote. It's undefined. So I have a vertical asymptote here at 5. All right? Now, the next part of this, we'll do this slightly different than a pre-calc way because you guys know limits. As far as what it'll do on the far edges, as x goes to infinity or negative infinity, that goes to end behavior. As x goes to infinity, what does this approach? The limit as x goes to infinity, what does it approach? Negative 1. Okay, these have comparable powers. The end behavior, you look here. As time goes on, the lesser powers mean less and less. These guys dominate, and they would start to approach negative 1. So I have a horizontal asymptote at negative 1, and that would be the same at the negative side. It would also be a horizontal asymptote at negative 1 on the negative side. Check? All right, then. After that, you could either sign test or kind of connect the dots, but the first idea here is I kind of know that if it's supposed to approach negative 1, it's probably going to be negative. But I could verify it. Don't worry about the hole in the sign test. Just focus on this. So say you did negative 3. The top is negative. The bottom is 5 minus negative 3, which is 3. And so overall I get negative over positive, which means the y's are negative. Follow the asymptote. Get to the hole. I'm not going to really change signs from the hole. I'm not going to change signs until I get to 4. When I look at this interval from 4 to 5, that's when I might change. Say I use 4.5. What's the top now? At 4.5, positive over 5 minus 4.5, which is positive. So I'm looking at y's that are positive. So what's it going to do between 4 and 5? Curl up and follow the vertical asymptote, yeah? Vertical asymptote's not there for goodness sake, it's there to be followed. All right, now, on the far right side, past 5, maybe 6, top is positive, but the bottom, 5 minus 6, is negative. So what's the far right side do? Is it here? Why not? Could be 2 reasons why not. First of all, that's got positive in it, so that's garbage. Another is that's got an x-intercept. There's no x-intercept over there, so that's just garbage in so many levels. If it's got to be negative, and it's got to follow both of these asymptotes, it's got to be down here. All right. Moving on to, okay, is this what's on yours? Okay, you said it's a +4 here? All righty. All right, this, I'm not sure if this is new for any of you. I don't, do you, people from Miss Pennon, have you heard of slant or oblique asymptote? Okie dokie. This will be new. Here we go. If you have more power in the numerator you will follow a slant asymptote. This will follow a slant asymptote. This will follow a slant asymptote. Would you also put parenthetically oblique? Some textbooks use the word oblique for slant asymptote. I want you to do both slant or oblique asymptote. Right? Previously, we've been doing horizontal asymptotes like the one we just did. This has a horizontal asymptote. The ones you have done forever, the ones that at the x-axis is an asymptote. This is part 3. Here we go. In this guy, first of all, are there any holes? This is negative x squared plus 4 over x. Is there a common 0 over 0 factor? No, no holes. Okay, not everything has it. What about x-intercepts? That's where the top is 0. The top is 0 at 2 and negative 2. Wouldn't you agree? Do you agree?
Yes.
Okay. What about vertical asymptotes? Vertical asymptote at x equal 0. Okie dokie. Now then, what about the end behavior? That's the start of this show. If I took the limit as x goes to positive infinity of negative x squared plus 4 over x, the top goes to negative infinity, the bottom goes to positive infinity. We could use L'Hopital's rule if we really wanted to overachieve. But what's the overall outcome just using end behavior knowledge? Which one will win? The top x squared or the bottom x? X squared. And so the end result is, first of all, will be positive or negative, negative, and it'll get bigger and bigger. So negative infinity. So it's going to go this way. It goes this way in the graph. But the question is, how? How does it go there? Does it go in a kind of a parabola way? That could happen. Or does it follow a line kind of way? Or does it kind of do this? How? Well, that's where the slant comes in. To find out, you divide. Dividing can come in 3 flavors, all of which I've given you in these notes. The easiest way in this case is to take negative x squared plus 4 over x and put them each over x. Now, this is awesome. It's an equivalent form. I know they look different, but each of these 2 forms of the problem give me different things to look at. This one, it makes it easy to see what's the x-intercept, or x-intercepts in this case, in the vertical asymptote. This one actually tells me the end behavior beautifully. As x goes to infinity, this remainder goes to 0. And you will see our graph starts to approach just y equal negative x. There is a slant asymptote of y equals negative x. Now, if I were to follow that, for example, if I put in, say I wanted to put in 7. If I put 7 into the equation, let's put it into here, I get negative 7 plus 4 sevens, which is a little above negative 7. Do you agree? So I would get something along the lines of here. And as I went further and further on, like at 100, then it would be negative 100 plus 400s. It would be just barely above negative x, right? So this graph is going to get closer and closer to that vertical asymptote. Now, as you get more into the origin, then that remainder has more of an effect. For example, look at x equals 3. At x equals 3, I get negative 3 plus 4/3. Negative 3 plus 4/3 would be like negative, 5/3. So you're talking more like starting to get a little diverge, a little from the asymptote. The asymptote is end behavior. It's a guide for when x goes huge, this remainder gets less and less of a function. But in here, we're going to just follow the points. Now, we could do a sign test for sure, and I could verify that it's negative out here. What about from 0 to 2? Sign test-wise, let's look at this guy. Or this guy. 2 plus x, 2 minus x over x. If I put in 1, so I know what's going on in this interval, I get positive, positive, positive. And so altogether it's positive. It's going to cross over here, but then there's that vertical asymptote at 0, so it'll probably curl up, because as x gets closer and closer to 0, dividing by tiny gets huge. We're going to get bigger and bigger ones, all right? I understand I'm doing the sign test kind of backwards. Sorry about that. But what about from negative 2 to 0? Say at negative 1. Let's look at the factor form. At negative 1, this is positive. 2 minus negative 1 is positive, but the bottom is negative. So in here, you're talking y is negative. So what's it going to do between negative 2 and 0 if it's got to follow the asymptote and eventually cross to that x-intercept? It's going to do something like that. And in the far left side, if I were to put in something like negative 5, something like that, I'd have 2 plus negative 5 is negative, 2 minus negative 5 is positive, over negative 5 is negative, so I have negative, positive, negative, which is positive. It's going to be positive, and it'll follow the slant asymptote. That is an oblique or slant asymptote case. It happens because the numerator in the problem was bigger power than the denominator. All right, let's try one like the second kind you might see, all right? So the top, any holes, first of all? Any common zeros? No. Any x-intercepts here? Are there any x-intercepts? No, why not? X squared plus 2 is always positive, so there are no, positive not equal to. So no x-intercepts. What about vertical asymptotes? X equal negative 1. So I have a vertical asymptote at negative 1. The end behavior. The end behavior, the limit as x goes to infinity of this function, which grows faster, the top or the bottom? Top. And so this will go to infinity on the positive side and negative infinity on the negative side. So it's going to do this and that, but now the question is how? So to find the how, we divide. Now in the previous problem, when I said divide, I said, oh, just put each one over x. Now that worked nicely because this one was over x. This one, not so much. Over x plus 1, you have to go about division a little better. What's another way to divide? Synthetic division. Synthetic division. Do you remember how to synthetically divide? Okay then, what goes in the box? The denominator factor you see, or the 0 of the denominator? 0, so negative 1 goes here. In the top, do I put the coefficients 1 and 2? No, you put 1, 0, 2 for the placeholder. Then what's the process or the algorithm? Bring down the 1, multiply and record it in the next space, and then add. Then do the same thing. Multiply, record it in the next space, and add. All right. Now rewrite. We just took the original problem, x squared plus 2 over x plus 1, and we could rewrite it after dividing as, what does this tell me? What's x, not x squared divided by x is x. X minus 1 plus 3 over x plus 1. That's the remainder, okay? It reduces in power when you divide. X squared divided by x should be x when you divide. So the idea for the slant is as x goes to infinity, the remainder goes to 0, and so y approaches just x minus 1. That's the big idea of the day. When you divide, the remainder term starts to go to 0, and so y equals x minus 1 is the slant. Y equals x minus 1 has a y-intercept of -1 and a slope of up 1 over 1. Now, we got the graph all subdivided, all nice. Now we need to figure out where's the graph go. Sign test wise, in this region, now don't worry about the signs created by the slant or the oblique. So don't think of this as 1, 2, 3 regions. There are 2 regions, right? The graph won't change signs on the other side of the slant. There's 1 region on one side of the vertical asymptote and 1 region on the other. There are 2 sign test regions is all you have to do. So on this region, left of -1, the top is, say, -5. The top is positive, the bottom is negative. All right, so it's got to be negative. So now it's decision time. Shall I graph here? No, that has an x-intercept I don't have, and it has a, oops, has the wrong sign. It's got positive in it. So to keep it negative, I got to go here, yeah? Now, this is only funny to me. It's just misery to you. But as I grade these, I'll get people saying, oh, so is the graph here and here? That kid doesn't know what the heck they're doing. Why can that not be? Give me one reason that can't be, and I can think of 2. Yeah, when you put in -3, how many numbers do you get out for the y? You get 1, not 2. When I put in -3, I don't get 2 points. Okay, the second is, say it in the title, it's rational function. It's a rational function. It should pass the vertical line test. Does this pass the vertical line test? No, it does not. Okay. So that's a big no. There's no graph up there. At any one x, there should be exactly 1 y, not 2. All right. In the next region, above 1, by x is greater than 1. Say x at 0. What do I get, positive or negative? Positive. So I've got to be above the x-axis and follow those 2 asymptotes. What's the shape? It's got to be whoopity like that. Okay? All right. By the way, I'm super picky about my graphs, so if you do some halfway lame thing like that, is that okay? Is that a function? Looks to me like you failed the vertical line test again. So yeah, that's garbage to me. I would take off of that, 100%. You've got terrible graph. Okay, that blue is bad. Boo. Boo you. All right. Okay, going on to the back side. So, all right, things are about to get a little grosser, but let me throw you a bone here, okay? I was going to give you a quiz today, but I just don't have time. So maybe I'll give it Monday or something like that. Now keep that in mind. No, you're getting homework. Okay, so here we go. The graph here, how's it factored? X times x squared minus 4, or x plus 2, x minus 2, yeah? In the denominator? Plus 3, minus 1. Are there any holes? No. Are there any x-intercepts? Yes. What are they? 0, 2, and negative 2. Okay, what are the vertical asymptotes? Negative 3 and positive 1. Yikes, that's 6 regions now. 5 interesting points, 6 regions. It's a sign test. Phew. Here we go. Now then, let's talk end behavior. What's the end behavior? Goes to infinity, which means there's a slant. We need to divide. Can you synthetically divide with a nonlinear divisor? No, you must use. Now you could actually use synthetic division twice. First divide by 1, then divide by negative 3. And that is one school of thought. My school of thought is you use long division. Okay? Yes, at this point, students say, oh crap, I don't remember that. That's been algebra 1. Well, it's review time. X cubed plus 0x squared minus 4x plus 0. All right then. The long division algorithm says you look at the first into the first. How many times does x squared to go into x cubed? One time? No. X squared into x cubed goes x times, or 1x times. Okay? If I divide x cubed by x squared, I'm left with an x. Now I multiply x cubed plus 2x squared minus 3x. Then I change signs. Draw the line. You better be zeroing out as you go over, so x cubed should go away. Negative 2x squared minus x, putting down the next term, plus 0. X squared goes into negative 2x squared. Negative 2 times, believe it or not, that's actually enough. There is a remainder here, but I don't really care about it. At that point, once I've got my constant, I know my slant is y equal x minus 2. You can go through and find the remainder and all, that's fine, but you don't have to. The minute you get down to the linear equation, you can call it good. Y equals x minus 2 then has a y-intercept of negative 2 and a slope of up 1 over 1. There's the slant. All right. Sign-wise, I will, in order for us to get through this, I will tell you the far region is negative. So, how do I, in this region, show always negative y's? This kind of parabola shape that follows the asymptote. After I trip over negative 3, then this will change sign, and therefore I'll get overall its sign change, so it'll go to positive. So if I'm positive, then I'm up here following the asymptote until I get to that point. After I fall over negative 2, this one changes sign, and I'll change sign overall, getting y's that are negative. After I fall over 0, this guy changes sign, so overall I have a y sign change. Now y will be
Good morning, Devlin.
positive.
Please rise for the Pledge of Allegiance.
Hang on 1 minute. There's one gotcha here still left.
Ready, begin.
I pledge allegiance
To the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Yes.
Isn't this?
All students, please check the lost and found tables in the main lobby to see if you have anything there. Items not.
Should it be through this? Yes, it should.
Remember to submit your original writing and artwork to Voices and Visions. We want to see your amazing work. Submissions are open until February 2nd.
Okay.
There are flyers in the main
Here's the part that you need to write yourself a note for. You're gonna go to positive or negative, so it'll be down here, and you gotta hit that x-intercept. Write yourself a note. Slants can be crossed. Slant is end behavior. So it really only applies down here. Slant can be crossed.
Senior high students, the AP Chemistry pretest for freshmen interested in AP Chem next year will be on Wednesday during lunch hour.
So it's gonna cross, hit that x-intercept, and then follow that slant.
Hey sophomores,
Just
if
like
you're
that.
interested in taking AP US History, there will be an informational meeting this Monday.
That's
Check in
good.
for 7th hour with your history teachers and proceed to the
Do you have any
auditorium
questions you
where-
want me to put up on homework? Oh,
High school spring athlete, the athletic online
you don't have to send it down.
Please register for your spring sports by February 12th. Thank you for your
I'll put them up over the weekend, and I'll take it Monday if you have
Girls
questions.
tennis players. There
What
will be
questions do you have?
Monday, February 4th, during 7th hour at auditorium.
What? Sure.
Yeah,
Extra
your
credit.
votes for the
How many points? Two, three?
Don't follow DHS.
Three.
Make sure to follow the
3.5.
Not doing it.
Fair, that's fair.
Okay, 5, 9, 18, 17. Okay, is that it? Huh? 20B?
Yeah.
Okay. All right. Let's go with okay. I'll say this, Laney made me feel guilty, so let's go one more. On set 80, let's go with 2. What's going on? 2, 3, 5, 8. Okay. All right. Let's spin for skips. What do you say? Go ahead.
What is he doing?
You can just tap anywhere inside the frame.
Lady, that was horrible. You should have landed on 2.
Okay, you can skip 5 problems up to 8. All right, you came out on the good. You're welcome. Yes.
So I have yesterday I had a headache, sorry.
Have a nice day.